Okay, so what we're going to walk through today is kind of three-dimensional graphing. So everything we've done up until this point has been what? Okay, two-dimensional. All right, so let's just put in two-dimensional. All right, from the origin, you could look right or left. All right, and we can think about that as horizontal. And then we could used to look either up or down, and we used to think of that obviously as vertical. Because on our papers, we had a plane that was flat on your desk, if you can imagine. But we're going to add another dimension, all right? From the origin, if we move to the right 3 units and then up 4 units, and then we go forward or backward, which you remember that was, you know, Catherine or who's in the back? Sebastian? Okay. So we got some possibilities then of a third dimension. So we're going to have to then do in what? We call it 3D, if you want to call it, or three-dimensional. Who's seen a 3D movie? Okay, and so they're trying to use polarizing lenses with different perspectives to cause your brain to see that three-dimensional concept, which is a phenomenal technology. Even though sometimes it looks a little weird, it still is a phenomenal technology that they're doing. All right, so we have 3 axes. We've got the x-axis, the y-axis, and we have the z-axis. I would encourage you, as we are doing our z-axis, that you cross your z, otherwise it's going to look like a 2. So just be really careful with that. So as we're going through. So I tried to draw this with color as much as we could. So you notice the X is kind of coming towards you. I want you to, can you kind of feel like you're sitting and you're in the front cube, and this point 0 is tucked at the back corner of the cube. So if I extend the x-axis backwards, that's all invisible until you get to the edge of the cube, in which case it becomes solid again. So I'm going to call that the x negatives. I'm going to call this the x positives, just to help you with perspective. I'm going to change colors for the y, and I'm going to make that red. So what you can see right now is the y positives. What you can't see behind this red wall, the y continues, and then it becomes apparent again. There's your y negatives. And now I'm going to go a third color. I'm going to go green for my vertical. What we can see is our z positives. And going below the surface, down where Trevor was, becomes our z negatives. So hopefully, and a dotted line means it's kind of behind a wall or something like that that you really can't see. Does that make sense so far? All right. So let's just pick a point. Maybe a point that's within, nothing greater than 4 or negative 4. So we're going to call this point T for Trevor. Trevor, give me 3 numbers, one of them at least being negative.
1, 4, and negative 3.
Okay, so here we go. So the x is 1. So where are we coming? Kind of 1 forward towards us. So here's x is 1. Where's y is 4? Make a little tick mark. There's y is 4. And where's z is negative 3? Down here. So you're kind of over and down. Now realize you're below the surface. Do you see that? Can you vision it? Can you envision that? You're below that horizontal plane. So I kind of went over and forward, and then I went down. Does it help to draw the dotted lines? Layla, go ahead.
What's that fourth dot at like you have the tick marks and then the fourth dot at the bottom right?
That's kind of the location. So if you imagine, Layla, I'm going 1 on the X. So here's my X with a red. Okay? And then I'll change to blue here. My Y is 1. And then my Z, I'm going down 3 units. And so if you imagine the XY plane is the horizontal plane here, I'm coming 1, 2, 3 down below it. It's very difficult to draw 3 dimensions on a 2-dimensional surface, which is why I tried to do that visual there to start us off and talk about where a point is. You know, that kind of idea. Does that help a little bit? And so maybe different colors, different stuff like that. Okay, so let's slide down. So what I want to do is I want to do a little bit of exploration here. So on your surfaces, what we're going to do right now is something that I think is pretty cool. We're going to pause our recording just momentarily, if I can figure out how to do this. All right. It's not pausing.
Does it record usually your screen too?
Click the boxes up.
Yeah.
Function. Pause. Oh, just resume. All right. So here's what we're going to do. We're going to kind of come back to here and jump to this first one. So when you're looking at this, you've got some different possibilities here, right? So first of all, what is it we're looking at? This point is 2, 3, 5. And so if I move this Z up, it's getting up way high. And if I bring the Z down, obviously now it's going below. So if we go to the point we had, which was that, 7, so you could move it to there if you needed to, just by moving all these over. And obviously that's gonna change it a lot. And so we no longer have 4 coordinates as we're working through it there. Now what happens, what is this doing? Who can explain that when you're moving it around like that? Catherine?
Showing a different perspective.
Yeah. And so this probably is your most normal perspective where you're kind of on a little bit of an angle and you're seeing it in there as we're working through it. But you can spin it to look at it in different ways. And this is very much like a CAD program. Has anyone ever done anything with a CAD program? Where you're graphing a 3-dimensional, like you might be graphing a room, or you might be graphing a house, and you can spin your room and look at it. Okay, that's all just working off of a graphical interface. And so the point being here is, hopefully this allows you to see where different points are from different perspectives, depending if your X is 0 or -1 or positives or things like that. So like right there. My X is 0, so I'm not at all off of the X-axis, and I'm just over on the Y and up on the Z. So let's put our phones down and stop looking at our surfaces for a second and just kind of look up here. So what axes are you on, kind of? What value is 0? Up here the X is 0, true?
Yeah.
Okay? And so I just want to show you, and so I would keep this, or I would maybe favorite this or something like that. So if you want to kind of explore more in terms of 3D, you can. All right, let's look at our other one. This is a program called Desmos, and the designer of Desmos has the passion to allow students to do any kind of graphing completely free. And his design is to create something that's manipulative and that's changeable and stuff like that. So the first equation they asked us to do was just x plus y. Okay? So when we just do x plus y, we get a plane. What happens though when you start to look at it? Okay, you can move it around and you can slide and you can change the plane. But what happens when you added in the x squared or the y squared? Do you guys know how to do squareds? Raised to the power of 2. Whoops. Is that how yours looked? Mine got like a parabola the first time.
Yeah. That's how mine.
Let's see. X plus y. And then where's the squared? Okay, there we go. So that's a parabola in 2 dimensions, kind of stretched out with parabola after parabola after parabola lined up.
How do you change it so that like it's doing it from that direction?
You can take it. How do you rotate it? I don't know how to rotate this one. I'm sure there's a way to do it, but I'm not sure off the top of my head. I think it has something to do with the x, but I'm not sure.
I found it.
Okay? So then the other one that we had, we also said, hey, what happens if we square that? So now we have this figure that kind of looks like a net that's hanging, but this is a 3-dimensional parabola. So you have a net that's hanging that's very, very steep. Now think about how a net normally hangs. A net that normally hangs is about the shape of what my arm is, like this, right? Okay? As a parabola goes, we're looking at x squared. Remember, 1, 1, 2, 4, 3, 9. But a parabola that hangs like this is really like 1/10 x squared. So if we wanted to flatten this out, you would have to put, low numbers in front of this to represent 1/10. Like I could put 0.1 in front of that, and I could put 0.1 in front of that. And now do you have a low net? This is a whole lot more like what you would have if you were suspending a net, maybe from a ceiling, and it was kind of making some kind of a canopy for your stuffed animals in your bedroom or something like that. Okay? Okay, a much more shallow net. But why did it get shallow? Because our parabola has a coefficient on it that was 1/10, versus our normal parabola has a coefficient that's 1. And remember, a 1x squared is very, very steep, which is why you had that extremely steep thing. And then the third one is the cosine, and cosine obviously does that cool curves and things like that, etc. So I wanted to show you these.
What about the fourth one?
Yeah,
I don't think I did it.
Can you plug it in?
You want to do that one?
Yes.
Okay.
It looks like it's like folded over itself.
All right, so first of all, we do cosine. Whoops, I have a decimal in there. Cosine of x plus y. Okay, so here's cosine. So first of all, let's just talk about cosine. Cosine is one of our trigonometric functions, and it goes in a cyclic function, and it starts up at 1, watch my hand, and it goes down and back up, and that's one cycle. And it goes down again and back up. And so it's like an oscilloscope, it goes on forever and ever. So what you have is a wave here. And you're looking at a wave. 3 dimensions in the ocean. You're looking at a wave. Now this wave is very consistent. However, when we added on a hyperbola to the wave, x squared.
Mr. McDonald,
Yeah?
what does all of that stuff mean? Like the cosine is not hyperbola and it's cosine.
That is trigonometry.
You've been in math class in here.
So x squared over 6. Then we have minus y squared over 6. Okay, so what you've just done is we've combined the wave of cosine, think of the ocean, with something called a hyperbola, which we're going to do in the spring, which is x squared over 6 minus x squared over minus y squared over 6. So you're combining something, two different functions together, into a 3D surface. All right, if this was a golf course, it would not be a nice one to golf on. Okay, if this was a mountain, I don't know if I necessarily want to be climbing it. But can you see the crest of the hill?
Yes.
Okay, the top of the hill kind of starts over here and runs along this line here. And then it drops down into a deep valley there, comes way up high on the slope up here, and then it drops way down into this valley, and then it climbs back up this slope up to this high point right here.
Was that like curved? That weird like funnel looking part?
So you're looking at imagine a net, and you've pulled it down in some points and pulled it up in other points. So just imagine this like flexible net that you can like take your finger and like push it up and pull it down and shift it and mold it, but you still have a plane that you've manipulated.
Why does it look like they're like crossing?
Well, because this part right down here is actually behind this part of the net. So it's coming up and then it's going back down, but you're seeing both of them. So you're seeing this part coming up and this part coming down, and you're seeing it like through my fingers through a crosshatch. And so this section in here, this little triangle, you're seeing two parts of the net, because you're looking through the net to the other part of the net. All right, so we're going to pop back to our draw board here. Now let's just kind of tie this together and bring this in conclusion. So, graphing. When we're graphing the x coordinate, all right, just as a little summary, the x coordinate, if you have a positive x, that's going to be coming forward towards you. If we have a negative x, that's going to be backwards, away from you. Okay, so that was, once again, was Catherine was forward and Sebastian was backwards. On the y coordinates, if we have a positive y, all right, that's going to be to the right. And that was over, who was over there? Was that you?
I was over there.
Lydia was over there. And if we have a negative y, that's going to go to the left, and that's where Krista was, over here by the wall. And then for our z's, if you have a positive z, and once again, I really encourage you to cross your z's, that's going to be thought of as up. And a negative z, with Trevor was way down low, okay, that is down for our points. So I have two examples here I want to go through with you. 3, 2, 4. Now I want you to be giving me directions like up, down, right, left, forward, backward. So first of all, the x coordinate, the 3 units. Which way is it?
Forward.
Okay, so that's forward, 3. The y coordinate of 2. So that's right 2. And the z coordinate of 4. Up 4. So let's try to graph this. So on the x coordinate, we're going to come forward 4. 1, 2, 3, 4. Put a little hash mark on the x coordinate at 4. If it helps, label that with a 4. Exactly. Forward 3. That's what I meant to say. Now go right 2. Put another hash mark at 2 and kind of draw dotted lines connecting those two spots. And now where do I need to go? Up 4. So 1, 2, 3, 4. So we're going up 4. So here we have the point 3, 2, 4. Now, so you don't have to stress about this. You're not going to have to draw these axes, okay? I'm going to provide you with them. Okay, so what we need to remember is X is forward and backward, Y is right and left, Z is up and down. But I will provide you with the axes. All right, let's look at the next one. 4, -2, -3. Okay, what's the 4 one? Forward 4. -2. Left 2. Down 3. So go forward 4. Go left 2. And now where do I go from that point? Down 3. So here we have the point 4, -2, -3.
Do we have to draw the dotted lines?
Do you have to? You get to. If you don't draw the dotted lines, no, if you don't draw the dotted lines, there's no perspective. You have no concept of how you got there. So it's critical to draw the dotted lines because it gives perspective as to where to go. Does that make sense? I hope. All right. So here's what we're going to do. Let's shut down this marvelous recording of you folks.
Yay.
You do realize that was all just recorded, Zach?
Yay.